All right. Hey, everyone. Welcome to another deep dive. This time today we have Rahul. I hope I pronounced that correctly. And he is with Connext Network. So I think I got your logo right here.
Nice. I
Yeah,
like
thanks for joining me.
cool. Yeah, thanks for having me. Happy to be here. And love the 2D logo drawing there, or
Yeah.
1D, I guess.
Um, so
Yeah,
yeah,
John
so
like
I had actually never heard of Connext until like probably 6 months ago. But you guys have actually been around a while. I guess, how did you kind of get started and how did you come to get to Connext and building it?
Yeah, totally. So the way Connect started, it was a different time back then. We started in 2017. I met the other co-founder Arjun at an Ethereum meetup in 2017 when I was just kind of like getting my hands dirty. This was in San Francisco, so I was going to these developer meetups, which were extremely high quality back then. It was like a small group of very focused people. I was kind of trying to find what I was going to do next and sort of met with Arjun. We really gelled around a couple ideas. Most of the ideas we talked about were around like, how do we bring Ethereum to the masses? How do we kind of like um, get this awesome technology into the hands and make it easy to use for people like our grandparents, things like that. So that was the origin. That's always kind of been the vision of Connext, even though our product has changed a lot along the road here. So initially we started out doing like fiat on-ramp type stuff. Long story short, that ended up not working out for various reasons because we didn't want to talk to banks and people like that. We just wanted to build cool tech and, iterate on the real problems that need to be solved within the space rather than kind of outside of the space. So then what we learned in like 2018-ish was that the real need is around scaling. So we kind of got into scaling, dove really deep, built state channel technologies. We built the very first like production state channel application on mainnet. This was in collaboration with Spank Chain, and then sort of that path took us into interoperability, believe it or not, because we kind of learned that our state channel bridge eventually became like, or our state channel technology eventually kind of became upended by rollups. And what we realized is that there's so many rollups out there, and all of these rollups are going to need connections in between them somehow. So then we also realized that our state channel solution worked really well for settling between different rollups. So that's kind of how we developed our first version of our Connext bridge in like 2020, which was the very kind of first interoperability based solution for moving between like Ethereum mainnet, Polygon, Binance Smart Chain, which were kind of like the big ecosystems at that time. So, from that point onwards, we kind of iterated on the technology, started out with state channels, moved into atomic swaps, and then now we're kind of on the third iteration of our bridge, which is a full, generic message passing with liquidity layer bridge.
For sure.
So yeah.
Yeah, excited to hear. I mean, I actually didn't know you guys were behind that. I remember the Spank Chain state channels when they came out, and I tried them out, and I was like, this is amazing. Like this is super fast and cool. Like I guess what do you like? Why back then did it not work out? Would you say? I know you had tried the fiat on ramp thing. Like was that part of the issue, or?
Yeah, no, so the reason state channels didn't work out is kind of because I would say the main thing is there's a lot of like off-chain complexity that application developers need to deal with, which is like, you have to synchronize states between two different parties, which means the way we did it was like you're storing a ton of this state in your browser. So then all of a sudden your browser has like the whole state, and then if you like turn off your browser, you kind of like get unsynchronized. Then if you can't move between different devices, you have to like install these heavy SDKs, and your browser like kind of like overheats with all the work that it's doing. It's not extensible, so like you can't build smart contracts on it. You have to build very specific applications that it only works for the very limited kind of set of use cases. People are like, oh, you could play chess on state channels and things like that, but that was like very much like the extent of sort of what you could do, and it requires liveness between the two parties. That's probably one of the biggest things. So you need like watchtowers and things like that. So at the end of the day, you know, rollups came around. Rollups are kind of like better in every way. So that's
Right.
kind of like people realize that data channels are kind of unnecessary at that point, but they are cool.
So I guess, how would you describe connext, top level, and then we can kind of get into the base architecture. Is it, would you guys say you're a bridge, or is it something
Yeah,
different?
so I would say, yeah, I think we are a bridge at the core of it, but what we've done is we've kind of built a modular execution layer. So what we have is we've kind of like split up the whole concept of bridging into its different various modules. So at the bottom, you know, you could even start drawing this stuff now, is you have like we built it into a stack where you have at the bottom of the stack, you have a transport layer. So this transport layer is basically what consists of, yeah, exactly. That's what I was going to suggest. So transport is like, how do you get messages from chain A to chain B? This could be, you know, varies based on the path, but this can be like a roll-up bridge contract. This can be like a multi-sig if it's like one of these other kind of more insecure bridges. It can be like a, you know, header relay type situation. So
Sure.
that's kind of the at the core, it's like, how do you get something from here to here if you're trying to go and create a path between any two domains.
Cool. So let's, yeah, we can just kind of start drawing it. I'm gonna take you off video and pin myself, and then later they will come see your face more. Yes. Okay, so we'll go with this is. Tell me if this is a bad use case, but you have like Ethereum and Polygon, and the Polygon app. They want to use the Uniswap v3 Oracle over on mainnet. Would that be a good use case? Like they want to read the state, or is that not?
Sure. Yeah, that's a fine use case. So then you have to figure out, how do you get this message from Polygon to Ethereum, or Ethereum to Polygon? You're saying Ethereum to Polygon, right? Sorry.
Yeah, would that be a good one? That would be.
Sure. Yeah.
Okay.
So, you know, if they want to read the Oracle, what do they have to do? They have to send a message from Ethereum to Polygon. So the most like native way to do this would be through the Polygon POS bridge. So the Polygon POS bridge has a set of validators that are watching the state of this, and they will basically take the fact that you sent this transaction on Ethereum, and they will relay it to Polygon for you. So they in turn, they provide this transport layer for you. That bridge does.
Yep. So there's I guess you could say like there's, we could draw. There's like this native bridge, you could say, that, and this is run by Polygon validators, and this is most rollups or side chains, I guess you could call Polygon. I don't know.
Yeah.
Most of them have these native bridges, but there's like some downsides to this, right? Like you have to pay gas on Ethereum to send the message, right? And then
yeah, you have to pay gas, and yeah, I mean, but you know, you'll see that you're never really going to get around that, because you have to have some mechanism.
Sure.
If you're going to send stuff from Ethereum, you're always going to have to send a transaction on Ethereum so that it can be read by any of these kind of middle parties that actually do the native bridging.
Okay, so then how would you guys do it in connext? Like, or would you guys be just using the native bridge?
Yes, exactly. So we would be using the native bridge in this scenario.
Okay.
So the way it works is we basically can pick and choose from any of these different mechanisms and put them together into this stack that provides like the full like bridging solution from top to bottom. So, you know, what we say is like, you know, why would we reinvent the wheel when there already exists this mechanism that is native to Polygon that provides the most secure transport and verification mechanism that you can get on the chain?
Okay.
Like,
So I guess what would connext be doing in this scenario, or is it just more of an interface for interacting with the native bridge?
Yeah, it's more of an interface, and you know, if you kind of like draw up the other layers, you will kind of like see how this sort of comes together.
Okay, so what do I draw next?
The next layer is going to be verification mechanism. So
verification down here.
Yeah,
we'll draw.
we can go
We'll go down.
upside down.
We'll
Yeah,
go, yeah. So
we
the
usually do it.
transport layer is this is the native bridge here, right? In this
Yes.
one. So in
And
this is the native bridge. And then what is the verification layer? Or is there a verification layer here? I mean,
yeah, it's a good point because in this case, it's both the transport and the verification layer.
right.
But the cool thing is with the connext solution, what we can do is we can add extra verification on top of this. So
Okay.
let's give an example and say we're not going from ETH to Polygon, we're going from like ETH to like Binance Chain or something like that. So Binance Chain doesn't have a native bridge mechanism.
Well,
So
I think it's their exchange, right?
sure. Yeah, it's they have some centralized mechanisms to get in between, but they don't have like a real like native mechanism.
Okay, so
So
maybe that's a better use case. We'll redraw. So like if there is no native bridge, then we'll come draw over here. Like so this would be like what is it now? BSC or BNB chain?
yeah, BNB chain. Sure.
Yeah. Well, it was BSC and now I think it's BNB chain.
Exactly.
So
They changed it so that they can get rid of the or distance themselves from the exchange, I believe.
yes. But anyway.
Yeah.
Okay, so if you're going here and want to do the same thing, then how does connext work?
So then you need some sort of transport. So I will you know, this can be like any sort of transport mechanism that already exists. So, or it can be like a new one. So we can say like, oh, we just want our trusted EOA Oracle to relay messages from ETH to BNB. But what we've done, because we've designed the technology as such, we have plugged into multi-chains messaging solution. So multi-chain has a like this any trust or any call or any call. Yeah, that's what it's called.
Yep.
So temporarily what we're using just to kind of get up and running because we want a solution to travel from ETH to BNB. We're plugging into the multi-chain solution, which is, it's just a multi-sig or a POS chain or whatever it is. It's a very insecure mechanism. This is not the mechanism we want to use for the long term, or it's not a mechanism that really we want to like have our users put their full trust into. So that's where the verification mechanism plugs in. So instead of just saying, okay, multi-chain, you're going to like create this payload on BNB and we are going to automatically trust that whatever payload you create is the correct payload that represents this like Oracle price that's coming from ETH to BNB. What we will do is we will add our own verification mechanism on top. So this is where the optimistic verification comes into play. So, over the past like 6 months or so, or, maybe even longer than that, we have been exploring optimistic verification methods for trustless bridging. We were working with Nomad for a long time on that. So they were kind of pioneering this concept around like optimistically verifying your bridging mechanism, where you have some sort of time delay in the period when a payload appears on the destination chain from when you can actually consider it valid. And during that time period, these watcher entities have an opportunity. So you only need one honest entity in that group of watchers who can prove fraud and point out that there has been fraud that occurred in this system.
So, and then I guess how this would actually work is this would probably be, guessing you guys would have a smart contract over here on BNB chain.
Yes.
So then multi-chain would put the data into this contract, and then basically anybody you would, if your contract wanted to read it, you would wait some time and wait to see if it gets disputed.
That contract on that you just drew there would have like a timestamp that says when is this route. It's basically a aggregated Merkle route of all the messages that are being sent. It will say, okay, this route is valid sometime in the future. It's not going to be valid right now because we
so you would multi-chain put the whole state of Ethereum or just the Uniswap Oracle balance that you've requested?
Yeah, that kind of gets into the weeds a little bit, but basically
Sure.
all the messages that get sent from Ethereum to BNB. So like, you could be sending an Oracle price, somebody else could be sending tokens,
Okay.
somebody else could be sending whatever.
So
So
it's a
all those get
subset of
aggregated into a
all the.
bundle, and then
Yep.
that bundle gets sent there, and then the messages get individually proven at the very end of the flow against this Merkle root. So the Merkle root is not going to be valid until, these watchers have had a chance to look at it and then make sure that it's okay. And since it's a fairly easy process to prove this, the time delay doesn't really have to be that long. It can be like, 30 minutes, 60 minutes, something that's short enough where it's still like okay,
Yeah, no, that's cool. And then that would be verified. And then I guess, are these guys staked? It's the question. Are the watchers?
That's a good question. The staking mechanisms are still being built out right now. So right now the watcher role is permissioned. So this is obviously not like an end state for connext, but this
Sure.
is kind of something that is happening in the short term. So we have a permission watcher set. Eventually, of course, these have to have some kind of incentive to provide the correct data. But yes.
So they'll be staked, and then and then I guess I guess if they're permissioned, it solves a lot of issues. But probably being like, how do you prevent them from just disputing and preventing any good ones up
exactly
there?
So now you're kind of getting into a lot of the complexities around like a watcher based system in terms of like how do you design the incentives so that watchers actually have incentives to watch, because there's nothing really in it for them particularly, but like you can design the incentives such that they have some kind of something that they get from this. But there's other ways we can design it, like our liquidity provider, the router nodes that we'll get into later, also running watchers and things like that.
And then
But the cool thing about this now that you've seen is these two layers, this watcher type optimistic layer and this transport layer, are completely interchangeable. We can change them out anytime we want. Like this, like right now in like an hour, I can be like, oh, I don't want this to be multi-chain. I want this to be like somebody else. I want this to be like something else. I want this to be like, layer 0 or like something like that. I want this. It just has to be a messaging layer. It could be anything. And like, we could build our own and say, okay, we're just going to have this like trusted EOA send from this chain to this chain. Doesn't matter, because it's just like the watchers are going to be able to see that there was some fraud and deal with it appropriately. But for ease of development, we've just decided to go this route. But we are actually also talking to teams that are building like ZK versions of this exact route, which is the BNB ETH route. And they have like, ZK proof, like header message verification, consensus verification in zero knowledge, that would be extremely trivial for us to plug in.
I mean, because that would just change what this is, the Merkle root.
Exactly.
It would just be
that would change
the whole chain, and then you throw it over there.
Exactly.
Yep. Yeah. I mean, that's like the end state. I feel like it's like, cool. We'll get to it's trivial to move it all over. And then I mean the question would be, how are you thinking about, when there is a dispute, who says that it was correct or incorrect? Will you have voting amongst your token holders, or will it be something else?
Right. I mean, you can always kind of go back and see that what the real state should have been on Ethereum, right?
So you would just like re-request it again, and then
something like that. You'd have to do something to unwind it. You'd have to re-request it, or you'd have to like have some other way to basically show. But it's very easy to like see at that point like what's the correct thing. If you're looking from off chain, of course it's very easy, but on chain is a different story. So
well, on chain, that's like the problem. They could just keep disputing it and preventing any good values from coming on chain and DOS your app.
Exactly.
No, this is it's cool. I think so I guess you were talking next, the relay layer. What is the relay layer, and what do they do, right?
So the next layer in this stack was going to be the liquidity layer.
Liquidity layer. Cool.
So, we have right now, basically what we have here is like a generic like messaging system that can pass messages from one side to another. However, we do think like assets and liquidity are like a huge part of the system that needs to be like thought about and designed. So what we do here in this case is we have these messages that go across and can actually like mint tokens on the chain that they need to be like minted on. So, you know, in this example, if you go ETH to Polygon here, you would have this message that mints some amount of tokens on Polygon. You would lock up tokens on ETH, and then the message that comes and gets delivered on the Polygon side would mint some tokens on Polygon. Same with
this would be a traditional token bridge, right?
Yes, exactly.
Yeah.
And then since these minted tokens are going to be like, you know, thin air tokens that don't mean anything, then you need a liquidity layer that has like you know, like stable swap AMM on the destination spoke chains that can actually like convert this into usable money. So you'd have an AMM living on Polygon, you have an AMM living on BNB, you don't have an AMM on Ethereum because that's where the like native assets are. Those only get locked, but then you have AMMs on all these other chains.
And you guys are running these AMMs?
No, so we deployed the AMMs, but they can be deposited in by anyone. And since they get like a share of swap fees, there's like, you know, rewards that go to users for providing liquidity to these AMMs.
So like the liquidity layer, like what would be an example of a token you want to lock and send over? Let's say it's, you know, USDC, you lock it and then you would mint them over here. And then your liquidity layer would basically allow you to do what? Trade these for these?
Your liquidity layer would allow you to send your lock your USDC on ETH, and then actually get like real USDC on Polygon, not just this minted version of USDC that doesn't mean anything.
Okay. Oh, so this is how it traditionally works. You guys do something different.
Well, that's how it works, but then there's another thing next to it, which is like the liquidity pool. So the liquidity pool would have 50% of this minted asset and 50% of the actual USDC.
Real USDC, and then this one would be like synth USDC or something.
Yes, exactly.
Yeah,
we call it XUSDC. So then it would be so then the user will be able to swap against this pool, and then it would be able to get their funds out. And then the cool thing is this pool has an ARB opportunity to not get unbalanced, because if the pool ever gets too unbalanced, you can always bridge the synth USDC back to ETH mainnet and unlock funds directly.
Oh, so, right. Yeah, you can. It's a two-way street.
Right. Yeah. So this is never going to be like really out of balance, or if it is out of balance, somebody's going to have a huge opportunity to like ARB the pool and make money from that.
Yep. Cool. So, and then, because I mean, the real USDC, you know, do they mint USDC on Polygon? I don't think so. Like, I think it just goes over the native bridge, right?
Yes, the native bridge mints USDC on Polygon. So
that's bridge, the one that you want, but the reason you would use yours is I'm presuming it's faster. And
it's not that it's faster, it's that we can actually control the minting of it, so we can send it to the other chains and whatnot.
Oh, okay.
We have to mint it through our own bridge, basically. Yeah.
Well, yeah, I was just saying, like, why wouldn't you just lock your USDC in the native token bridge from Polygon and send it over?
It's because you need a mechanism to be able to like burn it and mint it accordingly. Like if we want to send it to another chain that's not Polygon, we have to like do some special stuff.
Assuming it's not already over there, right? Or
yeah, exactly.
Yeah. Okay, cool.
Yeah. So then the final layer here is the execution layer.
Execution layer. Let's go.
Yeah.
Let's go black.
So
looks pretty with the colors.
Nice.
All right. What is the execution layer?
So the execution layer is basically a decentralized network of routers, which are basically like nodes in our system that are running software to be able to provide liquidity for users. Okay, so like, basically we've kind of like drawn this whole system out, and the way what you should think about the system is that it's slow, right? Because you have to travel across native bridges, you have this like, verification process that can take a long time. Um, so if you're just a normal user trying to send funds from like BNB to Polygon, you want that fast. You don't want to, because if you want BNB to Polygon, you have to go BNB to ETH, and then you have to go ETH to Polygon, because our system is like a hub and spoke system.
Yeah, well, how fast are the native bridges, by the way?
I mean, this ETH to Polygon is like 30 minutes or
Okay.
so, depending on which direction you're going. If it's like ETH to Polygon, it's like 30 minutes. Polygon to ETH is like 2 hours.
Oh, geez.
So,
Okay.
and then you add it up, and we use roll-up bridges as well. So like roll-up bridges, when you go back through the roll-up bridge, of course you have to wait the 7-day period, but like, we have bypassed that system through some magic that we've done to because of our verification mechanism. Actually, we can bypass the system because we can verify using our own verification. We don't need to go through the whole roll-up fraud proof mechanism. But all these things have time, and what we want to do is we want to provide the best experience to users, and users don't really need to wait that time. So what they can do is they can rely on this execution layer. So we have a decentralized network of routers. Anybody can be a router and provide liquidity in the system, and what they do is they basically front the money to the user, and then they get paid back by those like slow paths. So we have like a thing called fast path and things called slow paths. So user comes in,
cool.
they put their money down, they get their money in like, under 5 minutes. Then the router will wait, hours potentially, and get their money back
So like if
eventually.
you wanted to go, so you would lock some BNB here.
You'd actually burn it, but yeah.
Yeah, okay, so 100 BNB would be locked here, and then it would get sent over to Polygon, which is where you want it on, and they would get, say, what, like 99 BNB, and one of them would go to whoever's doing this, and he would basically take the multi-chain to the native bridge, and then he would he's getting paid to wait, you could say.
Exactly. That's correct.
Yeah, no, I like that. I think that's like the dream of optimistic rollups, right? So you have a more centralized service that, or not even centralized, but somebody willing to take on the weight risk and the unlock risk. But this was okay. So yeah, I like that.
Yep. And then you can, develop these verification mechanisms can be like ultra secure. You don't have this weird trade-off between like security versus like user experience. You can have kind of the best of both worlds. So you have an ultra nice user experience where like the front end works really fast, and then you have like a very secure like back end experience. So like the user doesn't even take any of like the risk in the system really, because the user will get their funds instantly. The router is the one who like takes the risk, kind of, if there is any risk, but has to deal with all the various underlying mechanisms.
Cool. And which tokens do you support for that?
Right now we're supporting USDC and Ethereum, ETH, like wrapped ETH.
Okay.
Just because we of course we want to support more, but like each of them has like a liquidity requirement. So we're starting off with like bootstrapping liquidity slowly in like the main assets, which we think are ETH and USDC right now.
What would be the liquidity requirements? Is it decentralized in the way that anybody can come swap the assets over for do this transfer, or is it more like pooled?
Yeah, it's pooled. So like I said, there's that AMM on each chain, so that one is pooled.
Oh, okay.
Then the routers have to come and run their own, and then they have to provide all the liquidity themselves. So the router liquidity is not pooled. However, transactions can be split across many routers. So many routers can chip in and say, we're going to split this guy's 100K transfer with 1K each over 100 routers, and
Yep.
and that, yeah.
Yeah. Okay. Yeah, I was like, could you like unbundle it and just have like this is being provided and minted by one guy? I don't know. But yeah, that's cool.
Actually, we are working on a mechanism to have routers be able to kind of like put this AMM liquidity into this AMM, and then use the LP token as collateral and borrow against it, and then use that to put it into their router. So, you know, we're working on ways to, of course, like, you know, optimize the liquidity requirements of the system and whatnot, but that's all kind of in the works still.
Yeah. No, that's cool. Because I mean, the risk with this piece would be somehow you send it over, and then for whatever reason you can't do it the native bridge, right? The native bridge breaks, but there's very little risk, so you would assume.
Exactly. That's exactly why we kind of broke it up this way, is because we
Yeah.
want to use like least risky systems, the best paths for each system for the whatever route. Of course, right now, like the BNB route, since there is no native bridge, is like the most kind of like risky route of the system, or the, you know, the least like native route. But you know, that's just how it is. So we have built what we can to kind of reduce those risks as much as possible.
Cool. Okay. What else am I missing here? I guess, do you guys have a token?
We do not have a token yet.
Okay.
We announced our token last year, but we kind of put it off so that we could focus on like building this new system and sort of get this launched and figure out, you know, how to exactly like design the mechanisms around the token.
Cool. Where's the token gonna go? Do we know yet, or have we?
We do not really know yet, but we have some ideas. You know, there's various parts in the system that are like decentralized networks that should and could use token.
Like these guys, or
yes, exactly. Those guys.
These guys and the relayers and stuff.
Exactly.
Those would be. Yeah. No. Let me know. We can come. We'll start mining some connext tokens.
Sweet.
It'll be
also,
cool.
If you're trying to be an LP or anything, the LP opportunity is open. Actually, I think right before this call, we just like announced on our Discord that the new system is open and ready to try. So this is very good timing. We're trying to kind of gain awareness right now. So
LPs, you need cash. That's
yeah.
You need the big boys.
Oh, so, yeah.
It's no, but this is cool because I think you could see sort of a lot of money sort of flowing through, and you could have like very little risk because it's sort of balanced as far as incentivized to move things back versus like normal bridges where you would just have these giant honeypots.
Exactly.
So, okay, anything else I missed on this? I think
there is like the whole like contract call piece. So like, you know, if you want to on BNB chain, like say, you know, this BNB Polygon thing here, then you can actually like call a contract on Polygon, and we have all the functionality to like support full messaging so that you could send like call data, and you can collect call data on Polygon. You can call any contract on Polygon essentially.
And this would be the execution layer, I'm guessing.
Yes, that's part of the execution layer. Yes.
So it would go here, and then you could send it over here. Would this be similar to like a keeper network? Like
yeah, I would say like keeper networks and relayer networks are a big part of the system in general, because all the transactions that happen on the destination chain are all done through keeper networks as well. So yes, we do use those heavily.
Yeah, well, because I think like in this one, so you would say like call, you know, update price on Polygon, and you would pay, I'm guessing, how would it work? Like you would pay a BNB or a dollar to somebody here to the network, and then they would go and execute it over here.
Yes, exactly. Right? Yes,
and then
exactly.
And then how would the verification work that it happened?
Yes, so that's another interesting question. So you get into the concept of like authenticated versus unauthenticated data. So for some types of data, you don't really need it to be authenticated, really, in the sense that like, so for example, like, okay, so I said like the router is the one who comes and fronts the money, right? So it fronts the money, it also fronts the data, and it's not going to get paid back unless it does that job properly.
Okay.
So that's the incentive for it to do the job properly. So for a lot of applications, that actually doesn't matter if the router can like change the payload or something like that, because for example, let's say you want to like from BNB, you want to deposit into Aave on Polygon. So you'll do this function called like deposit on behalf of, and then the router will come and it will call that function and it will deposit funds on behalf of you. And if it like lies, it'd be like, oh, okay, well, I'm actually going to deposit funds on behalf of me. Well, then it spent its own money trying to do that. And then that's actually not going to go through anyways. So the router's not going to get paid back. They just use their own money to
Well, but I'm
deposit
guessing
funds.
who would say they get paid back? Because like there would be this sort of message, I'm guessing an event on Ethereum or on BNB that says like call deposit deposit on Polygon. They would grab that message from the event and they would go and do it with their own money, right?
Exactly.
And then they would come back to BNB chain and say, I did it. Give me, or like do they already have the money over here on BNB? They already got the money?
Not quite. So at the same time this happens, it's also going through the slow path. So as it goes through the slow path, when it finally reaches on Polygon, then the Polygon message would be like, okay, well, the router already fulfilled this, so I'm going to mint these tokens to the router
Okay.
rather than minting them
So
to the user.
it would check in this contract, did that function get called? And
Exactly.
then mint it over. Oh, I understand. Cool. And then, yeah, cool. That works. No,
But then there is a complicated piece of this, which you did kind of touch on, was like, okay, so what if the contract call really does need to be authenticated? Say it's like a governance vote from BNB to Polygon. Then there's no money involved, so there's no router putting up its own money. But this is something that the router could like potentially be getting bribed to like mess with, right? So like this is a case where you really want to verify that this mechanism happened properly. So in this case, you can still send that data through our system. However, you have to wait for it to go through the slow path. So this is like a message where you're like, okay, I'm gonna have to take this like 2 hour wait or whatever because I want to verify the integrity of the data.
For sure.
We see that there's use cases for both of those, and some of the apps we're integrating with actually have use cases for both of them within the same app. They're like, oh, this one can go fast path because it doesn't need the authentication, but this message will need to go through the slow path. So it's kind of like you can design your app to make use of both of these and avoid the slow path unless you like really need it for like very like sensitive like admin level actions.
Nice. Cool. I think that's very good for drawing. I think, no, it looks really pretty. I think, what, I guess to finish up, like what chains are you guys live on now?
We are live. Our first little cohort of chains is ETH, Polygon, BNB, Gnosis, Arbitrum, Optimism.
Which ones have native bridges?
All of them except BNB. So Gnosis has their like Gnosis Omni Bridge or whatever.
Yep.
Rollups work really well for this system because they have like the most secure bridge built into their system. ZK rollups will work exceptionally well because they can go both directions basically fast, So yeah. But
well,
the cool thing is
sorry.
Even the rollup bridges, they have like batching mechanisms built in. So even if you go and you use like the Optimism bridge today, it's going to take like 30 minutes for your funds to show up. So it's like, even with our system, if you're doing that route, that would just be a normal like roll-up bridge route. You can use our system and get there way quicker because we just like bypass all that. And then the router ends up waiting the time. So it works out pretty well.
Yeah. No, that's super cool. And then, okay, so would you say like this is a prediction that I made is that like eventually all chains are going to have native bridges. Like everybody's just going to be natively bridged to ETH and all the chains will just be connected that way. Would you agree?
I would agree. It's probably in their best interest to do that. Yes. And I think, you could argue like, oh, why don't they just use like one of these like third-party bridges? But I think, people are very like scared of these third-party bridges right now. So I think a lot of the chains, like you said, will want to do it in a way where they can do it themselves, I think the way Polygon did it makes the most sense, where like the chain validators also are the bridge validators. So the chain is basically as secure as the bridge and vice versa.
Yeah.
That's, you know, that's a good way for like a alt L1 to do it.
Well, because I mean, we're super close. You have like what, Polygon, Cosmos, maybe Avalanche, and there's like not that many other ecosystems. So like if you just have like those guys do all go to ETH, then all of a sudden the whole blockchain ecosystem is connected, and it would be
Exactly. Yeah,
it
exactly.
would be wild. No, okay, so where, you know, like some of the, assuming we get to the future of everyone running native bridges, um, eventually they'll all, I think, as you said, probably move to some sort of ZK rollup type bridging, for really, really fast. Is where does connext fit in that world?
Yeah, so I guess what I will say is each of these different systems will have a different way of bridging to ETH. Even if they're all like ZK bridges or whatever, they will all have a different like ZK mechanism. And what we will provide is a standardized interface on top of them with standardized liquidity. So you can use the same liquidity anywhere. That's where the liquidity and the execution layer really come into play. We will have this liquidity layer and this execution layer, which operate across any underlying bridge mechanism, no matter what it is. So your liquidity will stay the same, your execution will stay the same, your like developer APIs will be the same. Everything will be the same, even if the underlying mechanism changes and becomes more secure, which is what we want.
So to translate that, I think it means like if you have, you know, 100 USDC on Polygon and you want to call some app that's on Optimism, you'll just, if you were building this and you had connext under the layers, you could call that function still, and it would still go through. You would just,
Exactly.
yeah, which would be very, you know, it would basically go to that call function thing, and then in the background there would just be a small fee to pay for somebody to take this
Exactly.
across. Yeah.
Yes.
No, I like it. And then, yeah, we'll be I'm gonna reach out to you for a bunch of stuff. There's a bunch of fun stuff I think we can do with this.
Amazing. Happy to.
Yeah. No, so I think anything that I forgot, or does this look solid as far as a connext?
This looks solid. I think there's one small piece we didn't touch on, which you kind of alluded to, which is the relayer fees. So the way it works is we charge the fee on the sending chain, and our relayers will execute it on the receiving chain and collect the fees on the sending chain. So
Yep.
basically what we have to do there is we have to like convert the gas fees, which is kind of like a complicated thing, but like you have to say how much BNB do you pay to get a transaction executed on Polygon.
Oh, right.
And that's like kind of like Oracle price conversion, but that is kind of what we think is the best user experience, because then you don't have to think about it. You just kind of send, you're used to sending gas already, so you just send like a little extra gas and it all works the same way.
Cool. All right. You know, you've been doing this since 2017, right?
Yeah.
Next, if you had to go back and start building your project, mistakes did you make? What would you change from how it started?
Yeah, it's a good question. I think probably, I mean, I think anybody on my team would say this right now, but like, you know, we came up with this idea for this new protocol, the way that it's come out now, back in February of last year, basically, is how we like decided on the whole Amarok upgrade. And it's basically taken us until now to ship it. So it's just, you know, it's taken a lot of time. It's kind of like sidetracked us from our effort around like making our bridge work properly. And like, you know, we kind of like abandoned the current system to focus on the new system. And I think, you know, there probably would have been better ways that we could have like iteratively gotten to this point without kind of like leaving the old stuff to build the new stuff. And, you know, I think what I've learned from this is like complete from scratch rewrites are not the best thing to do if you have like a working live product and it's up and running.
Cool.
Like, it's
Great.
fun, you know, we're engineers, we're builders, we love to just like, you know, just start from scratch, throw it all out, like greenfield everything. But you know, I think it's not like the right way to do it
It's the
if you're
fun
trying to
way,
like
but
build
yeah.
a company. Yeah, it's a fun way, exactly.
No, but anyway, this was super fun. I learned a lot, and it's a very cool cross chain messaging system slash bridge. So
Cool.
yeah. So where can people find out more? Where can they reach you? And then we'll leave it at that.
Yeah, Connext Network on Twitter, Connext.network on the web. You'll find links to our bridge there. You can follow us, you know, you can follow me as well.
Nice.
Yeah, so all of it's right there. Join in our Discord. You know, we have a huge Discord community. We're excited to kind of for this year, and I think this is really going to be when we step things up and, you know, focus on building the real things and providing the tools for people to build true cross-chain applications. So we're excited for the years ahead.
Nice. Well, thank you very much. And yeah, it was great having you, and we'll reach out more.